Now let us consider this question. It is based on the chemistry of a transition element, a metal A. It occurs in the form of its oxide. Metal is A, its oxide is B. Now B reacts with alkali in presence of oxygen to give another compound C. This compound C is green in color. All right. On acidification, compound C gives D, a pink colored compound. D is a pink colored compound, and this pink colored compound is also a powerful oxidizing agent. All right. C undergoes disproportionation reaction. C disproportionates to give D and B again. B already we have seen, it is the oxide of that metal. C on disproportionation gives D and B. All right. B, that oxide, with concentrated sulfuric acid gives oxygen. All right. Again, another reaction of B, it oxidizes HCl to chlorine. Okay. B, on heating to 530 degrees, forms another compound E. So, this problem involves a transition metal and its compounds along with their reactions. Now, let us consider C is green in color. All right. D is a pink colored compound. It is also informed D is a very good oxidizing agent. Immediately this comes to our mind. A pink colored compound which is an oxidizing agent is potassium permanganate. So, some catchy points we can get from this. So, probably D, the pink solid, is potassium permanganate, which is a powerful oxidizing agent. All right. If the pink solid, which is a good oxidizing agent, is potassium permanganate, naturally metal A should be manganese. And it exists in the form of its oxide B. Manganese exists in the form of MnO2. In this connection, I want to mention this MnO2 is given another name, pyrolusite. It is not given. If it is given in the problem, immediately you can come to the conclusion that B is MnO2. It is not given. But we know pyro is MnO2. So, A is known, B is also known, and from this D, it is also known to be KMnO4, which is a powerful oxidizing agent. Let us see. B, namely MnO2, reacts with alkali in presence of oxygen to give C, which is green in color. It is quite obvious. In the method of preparing potassium permanganate from MnO2, this reaction gives a green compound which is potassium manganate, K2MnO4. So, A manganese, B MnO2, C K2MnO4, D KMnO4. All right. C is potassium manganate. In potassium manganate, manganese is in +6 state. In potassium permanganate, manganese is in +7 state. It is given here C disproportionates. I think you are familiar with disproportionation reaction. A disproportionation reaction is one in which the species gets oxidized and also it gets reduced. So, a particular species on disproportionation reaction forms a compound in which the metal is in a higher oxidation state and another compound in which it is in a lower oxidation state. Now it is given C disproportionates, namely potassium manganate, undergoes a disproportionation reaction. So, two compounds result from the disproportionation reaction. Since C contains manganese in +6, in one of the products manganese should be in a higher oxidation state and in the other product manganese should be in a lower oxidation state. Let us see what are the products. The products are D and B. Already we have seen D is potassium permanganate. In potassium permanganate, manganese is in +7 state. So, from +6 to +7 oxidation. Another product is B, but we know already B is MnO2, in which manganese is in +4 oxidation state. Therefore, disproportionation reaction of potassium manganate gives a product containing potassium permanganate and manganese dioxide MnO2. And some reactions of manganese dioxide follow. Manganese dioxide with concentrated sulfuric acid gives oxygen. It is a method of getting oxygen. MnO2 plus sulfuric acid gives oxygen. Similarly, MnO2 behaves as an oxidizing agent. Manganese dioxide is also an oxidizing agent and it oxidizes HCl to chlorine. It is a method of preparing chlorine. Then another point regarding manganese dioxide, B on heating to 530 degrees centigrade forms E, a new compound. Up to this stage, there is no mention about E. B on heating to 530 degrees centigrade forms E. All right. What is E? We have to find out. All right. What are the questions? What is A? We come to the conclusion that A is metal manganese. This comes from green colored solution, potassium manganate, pink colored compound, potassium permanganate, and so on. Second question, what is its ground state configuration? Since we know metal A is manganese, its ground state configuration is 3d5 4s2. 3d5 4s2 is the ground state configuration of manganese. Third question, what is C? Already we have seen C is green in color. It is potassium manganate. So, C is potassium manganate. What are B and D? Disproportionation reaction of C. B is MnO2 and D is KMnO4. What is E? Of course, nature of E is to be decided from the last reaction, namely B on heating to 530 degrees centigrade forms E. Now, in several of these reactions, the temperature effect is very important. And in the case of manganese dioxide, this temperature of 530 degrees Celsius, this converts MnO2 into Mn3O4. Mn3O4 is formed. You may ask, why not other oxides of manganese, MnO, or some other compound. The reason is this temperature, this value decides the nature of the product. During the action of heat of MnO2 to 530 degrees, it is converted into Mn3O4 only. So, a type of question like this, you have to grasp some points somewhere in the problem, either in the beginning or in the end or in between. If you get a clue from that, you can reach the beginning of the problem or the end of this problem depending on the nature of reactions. Of course, why I have chosen KMnO4, or I can also choose K2Cr2O7, because this potassium permanganate, it is a very powerful oxidizing agent which is used in organic chemistry, in volumetric analysis, and in your syllabus the chemistry of KMnO4, starting from the method of production of this compound up to its use, you are familiar with. So, I have chosen this problem since you are quite familiar with KMnO4. Similarly, you should be quite familiar with potassium dichromate, which is another important oxidizing agent. But of the two, potassium permanganate is more important in several ways. Probably you remember, of course, in order to lengthen this problem, I should have added one more reaction also here in the form of a reagent. You are familiar with Bayer's reagent. Bayer's reagent is cold dilute solution of potassium permanganate. If I have given the name, you would have spotted that compound quite readily, but I have not given it. Instead, this pink colored solid, which is a powerful oxidizing agent, that is the clue from which we can get the compound to be potassium permanganate, and from that all other conversions are easy to be observed. I think I have followed the discussions I have made. For the sake of completion, I will give the answers. As we have discussed, from this you might have understood. A, metal A is manganese. B, what is its ground state configuration? It is D5S2. Since we know the metal is A, its configuration I can easily write. And C is potassium manganate, which undergoes disproportionation reaction. Then fourth, what are B and D? I'm sorry, this is 1, 2, 3, 4. B is MnO2 and D KMnO4. Fifth question, action of heat on MnO2, it is Mn3O4. I think this completes this problem. So from the discussion you might have understood, and for the sake of completion I have given the answers.